So for question 5, it's about energy, power, and efficiency. So for the part A, it is quite straightforward. To find the gain in GPE, we just need to measure at the bottom of the lift shaft versus at the top of the lift shaft, what is the change in GPE. So gain in GPE basically means final GPE minus the initial. We set ground equals to 0 at the bottom, so initial GPE will be 0, and when you rise up, we are always referring to the vertical gain in height. So once you substitute that into it, you will find 64,000 joules. Next question, we are checking whether you are good at how you visualize energy conversion and whether you understand efficiency. Now, if you think about this, when the lift goes up, it gains 64,000 joules. Where does this 64,000 joule come from? Is it within the same lift system? No, right? This gain in GPE has to be supplied by an external source. And the only external source over here is the motor. So it means that the gain of GPE by the lift has to come from the motor. And the way we say it technically in terms of energy is that if the energy comes from an external source, we call it work done. So we will call the energy that transfer from motor to the lift work done by the motor. Well, once the lift receives this energy from the motor, it will convert it into GPE, and because of that, the lift will rise, right, to a higher point. You notice that I didn't include kinetic energy, right? Because when we are doing energy conversion, we are focused on the start and the end point. We don't talk about the process between that. And the movement, kinetic energy, the movement between the bottom and the top of the lift shaft is within the process, right? At the start of the lift journey, the lift started from rest. So at the start point, at the bottom of the shaft, there's no KE. When the lift reaches the top, it will stop at the top, right? So the final state of the lift also have no KE because it's not moving, it stopped, right? So because of that, we can write down our energy conservation. Work done of the motor is equals to gain in GPE, but now there's efficiency, right? So it means that only 80% of the work done by the motor has been converted into GPE when it transferred to the lift, right? So that is what the question is telling us. And he wants us to find out the energy required. So we want to find the purple highlighted energy. So now what we need to do is, we know the gain in GPE we have calculated is 64,000 joules. So we do not know how much work is being done by the motor. We have to find out. But we know that 80% of this work done is actually equals to 64,000 joules. So to find the work done is actually quite straightforward. It's just 64,000 divided by 80%, and ta-da, you will get the answer, which is 80,000 joule. And it makes sense, right? It means that if you supply 80,000, only 80% will be converted, will be absorbed by the lift, right? The other 20% may be lost somewhere, right? So that's what it means. Power supply by the motor. So the motor need to supply 64,000 or 80,000. Of course, need to supply 80,000. If I supply 64,000, the lift will receive even lower than that, and it cannot rise out of the shaft, right? So because of that, power of the motor, the E stands for the amount of energy that the motor produces, 80,000, even though 20% of it is lost somewhere. And it has to keep on supplying for don't know how much time. So we need to find out how much time that the motor need to supply this 80,000 joule. So if we look at the data here, you can actually see that there's a pair of data that can let you know how long does it take for the lift to rise from the bottom to the top, right? So the pair of data is actually over here. The leaf will travel at 0.4 and it will rise up diagonally. So this speed need to cover this 16 meter. So because of that, we can actually find out the time taken for the leaf to complete its journey will be distance, which is 16 meter over the speed, which is 0.4 meter per second. So with this time taken, you can substitute into here. And if you go and do the math on your calculator, you should get the value 2000. So that's how you solve this question.